Hello everyone, I am Mowli Raj, Assistant Professor, Department of Computer Science and Engineering, Sri Shanmuga College of Engineering and Technology. Today we have see about data structures, hashing techniques. Okay, we have see about the detailed explanation in next slides. Okay, hashing techniques. Hash table data structures is an array of some fixed size containing the keys. It associates keys with values. The key is string values associated with the record of example salary. The implementation of hash table is called as hashing. It can be performed insertion, deletion, and find the operations in a constant average time. Each key is mapped into some number in the range 0 to table size -1 and placed in appropriate cell. The mapping is called the hash function, which should be simple to compute and should ensure that any two distinct key gets different cells. Okay, this is the example diagrams for the hashing. Here John has us 2 3, Bill has us 2 4, Deva has us 2 6, Mary has us 2 7. Okay. Next, problems in hash tables are choosing a function, is it deciding the table size, deciding what do what to do when two keys hash to the same value called collision. Hashing function is the key to address transformation. Key percentage table size. Example, table size equal to 10, key equal to 75, hash key 75 modulo 10 equal to 5. It is a simple hash function. When input keys are random integers, then this function is very simple and distributes the key evenly. If the table size is 10 and all the keys end in 0, then this hash function is wrong choice. If the keys are string, the hash function need to be choose carefully. Option one option is to add the ASCII value of the character in the string. Hash has const char star key in the table size. Okay, if the table size is lost, the function does not distribute the key well. Next, this hash function requires the key has at least 2 character plus the null terminator. The value 27 represents the number of letters in the English alphabet plus the blank 7 to 9 is 27 square. This function examines only the first 3 characters, but if these are random and table size is 10,007, so 26 cube equal to 17,576. Possible combinations can be mapped without any collision, but only 28% of table can actually to be hashed. A good hash function index. This is the example program. Next, collision avoidance strength is in hash table. The hash function takes some key value as input, perform some mathematical calculations and generate the hash key position in the hash table where the key will be stored. Collision, if two different values are indicates to be stored at the sum uh, as the same at the same position in the hash table, this situation is termed as a collision. So hash function must be designed in such a way that the possibility of collision is negligible. So several collision resolutions techniques are used to overcome this problem. These techniques are separate chaining, rehashing, open addressing, and extensible hashing. Separate chaining. The separate chaining technique used to link list to overcome the problem collision. In these techniques, all the keys that hashes to the same hash values are maintained in a linked list. This method keeps a list of elements that hash to the same value. Example, table size 10, input keys are the first 10 perfect squares 0, 1, 4, 9, 16, 25, 36, 49, 64, 81. Hash function as of x equal to x mod 10. This is the example of separate chaining hash table. Next, find the perform find. Use the hash function to determine which list to be traversed. Then traverse the list and return the position where the list is found. Insertion, to perform insertion, traverse the appropriate list and insert the number either at the front of the list or at the end of the list. Advantages, more number of elements can be inserted because it uses array of linked list. Disadvantages, it adds the overhead of maintaining multiple linked lists. To use the use of pointers requires more memory space and slow down the program. Next, open addressing. Open addressing is also known as close hashing. It is an alternative method to resolve collision with linked list. In this technique, a block of memory space is reserved for storing the hash value. If any collision occurs, alternative locations are accessed until an empty location is found. Hash function hi of x equal to hash x plus fi mode table size. Next, linear probing. Probing is the process of getting the next available hash table array cell. In linear probing, f of I is a linear function of I. That means alternative locations are searched in a sequential manner. Thus, f of I equal to I. Example, insert the keys 89, 18, 49, 58, 69 into the hash table. This is the example diagram of 9 values 0 to 9, empty table after 89, after 18, after 49, after 58, after 69. You have some get values. 89 is inserted to your slot 9, 18 is inserted to your slot 8. When 49 is inserted, collision occurs at the slot 9, so put it in the next available location slot 0, that is hash 89 equal to 8 mode 10 equal to 9, hash 18 equal to 18 mode 8, no collision, no collision, hash 49 equal to 49 mode 9, collision occurs. Okay, this is the collision occurs in 49 values and 58, 69. This is the examples collision occurs or not occur in some ranges. Quadratic probing, the disadvantage of linear probing is that it leads to clustering of key values at one place. To eliminate the primary clustering problem, quadratic probing method is used. In this technique, f of I equal to I square. This is the example of 89, 18, 14, 59, 69 tables. This is also the collision occurs or not. We have make the 18 mode 10 equal to 8, no collision occurred. Mode 49 mode 10 9. The hash 49 f of 1 mode 10 collision occurred in these steps. We have followed up to end of the values up to 69. Next, what are the advantages? Easy to implement, less clustering. Disadvantages: it forms secondary clustering. It will not search all locations in the hash table to find empty slot, so it takes longer time for insertion. Next, double hashing. To overcome secondary clustering problem, double hashing techniques is used. It uses two hash functions to arrive at the hash value. F of I equal to I star hash 2x, hash 2 of x equal to r minus x mod r, where r is a prime number smaller than table size. This is the example values of example tables given to the some collision occurs or not occurs. This is the example occurred. You have a refer it. Next, rehashing. When the hash table becomes too full in open addressing hashing, the successive insertion operation will take more time to complete. To overcome this situation, rehashing techniques is used. In rehashing techniques, another hash table is built, that is about wise as a big scan down the either original hash table, computing the new hash value for each element and inserting it in the new table. Example, insert 13, 15, 24, 6, 23 into a hash table of size 7. The hash function is h index is 7, the mode x mode 7. Okay, now the table is 70% full. Since the table is full, a new table is created. The size of this table is 17 because this is the first prime, which is twice as large as the old table size. The new hash function is then h of x equal to x mod 17. Now the old table is scanned and the elements are inserted into the new table. The inserting table is 0 to 17. Some values given. This entire operation is called rehashing. Rehashing can be implemented in several ways. Rehash as soon as the table is half full. Rehash only when an insertion fails. Rehash when the table research a certain load factor. Extensible hashing. The major problems in using open hashing or closed hashing is that collision could cause several blocks to be examined during a find, even for a well distributed hash table. And when the table gets too full, an extremely expensive rehashing step must be performed to avoid these problems. Extensible hashing is used. In extensible hashing, a hash table is stored in the main memory and the buckets to store in the disk. Each value in the hash table is pointed to a bucket. In the secondary memory, the hash function is applied on the input value to generate the bucket pointer and perform then store the retrieve operations. Examples: consider our data consists of 6 bits integer values. The root of the tree contains 4 pointers determined by the leading 2 bits of the data. Each left has up to m equal to 4 elements. If each left the first 2 bits are identical, this indicate by the number in the parenthesis. D will represent the number of bits used by the root, which is sometimes known as the directory. The number of entries in the directory is thus 2D is the number of loading bits that all elements of some leaf L have in common. They are less than equal to D. 0001101 we have divided in 4 bits 2. Suppose we want to insert a key 100100. This word go to into the third leaf, but as the third leaf is already filled, there is no room when the split into leaf into the two leaves, which are now determined by the two first 3 bits. This recurs increasing the directory size of 3. These changes are given below. This is the some example diagram of rehashing methods are very simple, quick access time for insert and find operations on large database. It is disadvantages. This algorithm does not work if there are more than m duplicates. Thank you.